Well, hi, good morning, and thank you so much for joining me in my shop here on June 22nd. A day of rain here. It looks like it's going to rain all day long. It rained all through the night, so lots and lots of rain here. So, I pretty much finished this radio. This is the broadcast only version of this radio. And I've changed all the capacitors, all the paper ones anyway. There's nothing left in here like that, and fantastic. So, but I'm not going to operate the radio. We're going to set it aside. And I'm going to focus now on this guy. Bring him up to speed. Oh, there is one last wax capacitor back on the antenna there, but I don't think I'm going to worry about that. That is nothing more than for hooking up an external antenna, which I hope nobody ever does. Actually, you know what? That is a bit of an important capacitor, because you could get a shock through the antenna. And I think the capacitor is there to try to reduce that possibility. I'll have to attend to that later. Okay, let's take a look at this guy now. So I was doing the comparative thing with these two radios, and I stopped because I couldn't really compare them, at least in the front end area. The part layout's a little different, everything's a little bit different. So one of the interesting things I did with the last radio was an experiment with the AVC capacitor. Now, can I find that same capacitor in this radio? I should be able to. Okay. Let's see if we can do that. I may have changed it already. AVC capacitor. Okay, let's go looking for it. Okay, so this is the version of the radio I have. Wait a minute. Yes, I have on my bench right now. So AVC capacitor, or what I commonly call the AVC capacitor. So we'll start by looking for the volume control. Here it is here. We follow up from volume control, and here's the output of the detector. There's a couple diodes in there. And we have the RF filter capacitor here. And then we run AVC DC voltage this way through this gigantic resistor, and on the other side we should find a capacitor. Hey, what happened here? Oh, here it is. So this is what I've been calling the AVC capacitor. In my mind, it's a bucket, a charge bucket set on this high impedance circuit on this side of this big resistor. And you fill the bucket and empty the bucket. How do you empty this bucket? You must empty it back through this resistor. So as it fills and empties slowly, it maintains a fairly steady voltage here, which is related to the strength of the signal coming through the radio, and it's detected or rectified here. So I always thought of this as a bucket, and it does serve that purpose. It does slow down the variation in the voltage here, which is the desirable thing for the automatic volume control voltage to be fairly steady and not jump around. Why would it jump around? Well, bolt of lightning puts a crash through the radio, crash sound, that causes, for a moment, a very strong signal here that can be rectified, and that causes a jump in the DC voltage here, which will cause a jump in the voltage over here. But with this capacitor there, the momentary jump would just be absorbed by the capacitor, so you're not going to get a big fluctuation. Otherwise, what would happen is the lightning would crash and the volume would drop on this radio and then slowly come back. So that's one purpose of this capacitor, and maybe I'm describing this very poorly. Wait a minute. Yeah, this capacitor here. But what I noticed in experimenting with the other radio is if you remove this capacitor and operate the radio without it, you can see audio here, some audio signal. In the other radio, the RF was pretty much all snuffed out back here by this capacitor, so there's no RF coming through. But the audio was visible. So I think now another purpose, and maybe even the main purpose of this capacitor, is to knock out any audio that's made it here. Because of course coming out of the detector is a combination of the RF and the audio signal. So maybe we can repeat these experiments with this one if I can find where this is. A 0.05 just past a 2.2 megohm resistor. And the other side of it is tied to the B minus. Which is that the chassis in this radio? I don't think so. Talking about that. So how is the chassis tied in? Let me see. There. See, this is the shell of this tube. Why did he draw a big long line down to here? Why didn't he put the ground symbol here? And is that really true? Well, it shows that it's pin 1. I believe this would be pin 1. Pin 1 is typically the shell ground for a steel case tube. That's what that's got to be now. This one, same thing happening here, but look. Well, what's that? Oh, back to B minus. They didn't do that over here. Huh. Okay, and is there another one with it? Here's one here. Is this a glass tube? Are there any glass tubes in here? Yes, there are. So the glass tube would be, looks like the output tube is glass, and the IF amplifier is glass. This one is glass. Yet they show this ground coming down. This glass tubes don't have this connection. I don't understand what's going on here. This was once not a glass tube. Maybe the glass tube in this radio is it is a replacement. I'm the one who stuck it in there. I picked a glass tube here. Maybe I shouldn't have. Yeah, man, I should find another 12SK7 that's got a steel case on it. We'll stick with the glass tube for now and experiment later. And this one over here, no, this one's not. Well, it might still be a metal tube, but if it is a metal tube, doesn't it have some kind of grounding on the? So they're showing this one maybe like it's a glass tube. They didn't put the GT or anything out here. Oh, they put it here. GT on the output tube. Yes, it is a glass tube. What about this guy? So if I put if I put a metal tube in here, I don't know. I don't know what would happen. Can you? Is there such a thing? I'm sure there's 12SA7 metal tubes. I'm sure there are. Okay, enough. I'm just wandering around here, gawking at things, waiting for something important to appear that I haven't realized yet, but nothing like that is popping up. Well, stuff like that is popping up. Nothing too extreme. Extraordinary. I was looking at the ground connections when I got all balled up in the metal tube thing. So there is no tie to the chassis. There must be somewhere. There must be somewhere. Somewhere. I'm looking for a capacitor and a resistor. I don't see it. That's odd. You know, it's probably in here somewhere, and for some reason my eye is just not catching it. So, I mean, there is this grounding. That's not the... Let's look at how this antenna is done. The antenna comes in, goes through a transformer, comes down, goes through another transformer. Now, where's the antenna signal go from here? Goes into the, this is the B minus line here. So essentially the antenna's feeding through these transformers into this negative or B minus line. The B minus line is connected directly to one of the lines coming in, the power plug. If you have this plugged in the right way, this is grounded through the hydro system. It's not very good, but even if you plug it in the other way, you still pick up some grounding effect. So that's what the antenna is trying to do. It's trying to work through these transformers and out to ground through this. That's what I believe. I believe that's what it's doing. Don't ever take anything I say as true. Just, you know, partially true. And that's, so I don't know where is the chassis drained back. I don't know how this works. This connection, this has to be it. This is B minus connected through a capacitor. Oh, it's a big point too, also through a capacitor to the chassis. It's just drawn it in such a way that my head can't understand it till just now. Okay, enough of this. What we want to do is we want to locate the AVC capacitor. Where did it go? I've lost complete track of everything here. Let me just track back through here, and we find it there. That guy right there, 0.05, right, with the 2.2 mega ohm resistor, and it's going to be near the volume control. Maybe not. Okay, let's look for it. I spent a lot of time looking at the schematic there. Let's see if it paid off. So we're looking for a 2.2 mega ohm resistor. There's one right there. It's a capacitor to ground right here. It's a 0.05. The other side of this resistor goes into a little bit of a complicated deal there. I think that's the one. I think that's got to be the one. I mean, this is the audio one carrying the audio from the volume control over to the triode. These ones, I don't know what they're doing. They're in the front end somehow. This is the guy. So if we want to experiment with this, this is the one we would cut and repeat all the same experiments as yesterday. Why not? Okay, I'm going to have a little coffee and then we'll get down to it. I got the radio just about ready to go and ready to play it and just see what its baseline operation is, since I can't remember. But I noticed something very curious right here. We're going to take a look at it with the close-up camera here and wonder what the story is behind this. So right in the center of the screen you can see a little piece of wire with a green covering on it, and the wire's cut, and that's just the end of it. What's going on there? That's not me who cut that wire. And that wire, the covering looks like the kind of stuff that's on all the original parts. There's the original part here, and somebody cut it away. And then what? So if you look at the terminal that it's attached to, you see there's a bare wire running out of view of the camera, both left and right. You see bare wires in a radio like this, often they're bare. They're bare because they're slightly cheaper than an insulated wire, and they're almost always ground wires or B- wires or something like that. So in the fact that's going, between terminals, it really looks like they're just extending the B- wire, if you like, through a number of terminals, and then those terminals become good places to make connections for a B-. That's probably what this was, probably a capacitor connected there, or something connected there, assumably a capacitor, and the last guy decided to connect it somewhere else. Oh yeah? He did? Connect what somewhere else? That's the question. Okay, let's look at the bigger camera here. Now, I've gone ahead and replaced a number of stuff. Am I just forgetting what I myself did? It's possible. I don't think so, though. So, here's a capacitor I installed, and I brought it over to the ground terminal here. Maybe the capacitor the last guy installed also went here, but originally went here. I don't know. I like having a story around these different things I find in these radios. Makes me feel a little more comfortable, or I may actually think something useful up. I mean, it may tell a story worth figuring out. I don't think in this case, though. So, okay. So what have I done here? I've got all kinds of stuff hooked up to the radio. So first, this is a ground connection, or B- connection. This is not a B- connection. What happened to my other B-? I guess I removed this while I was messing around here now. So this is the scope ground. That's also another B- point, connection point. Actually, you know what? It was doing this when I spotted the wire and then spotted the wire. In fact, I can connect this over here even better. This is a better spot. Yeah, that's good and solid. That's good and solid. Good. So that's ground. That's ground, or B-. I was just showing you what this is. Just going to this goes to the vacuum tube voltmeter I've got over here, the ground side of it. Then this is, of course, my scope ground lead. This is the point where the AVC capacitor connects into the circuit. The other end is grounded here. Connects in here. The 22 or 2.2 mega ohm resistor is just behind here. You can't see it. So I'm on the capacitor side of the 2.2. I'm on the business side of the grid side, let's put it that way. The grid side of the 2.2 great big resistor there. Good, I think everything's ready to go. And the object here is to play the radio and get familiar with it before I start making a lot more changes to it. And I also have the AVC meter connected here. This is going to my voltmeter over here. And there's the voltmeter. There it is. And the scope. I have the scope connected to, I should turn it on. So I've got this on. We'll set this to 15 volts full scale, and I think everything's ready to go here. So what I'm going to do is I'm going to stop, go have some coffee, and then we'll make this actually happen. Okay, I think I'm ready now to try this out. Okay, first of all, switch is off. If I remember right, is this the one with the switch that doesn't turn off? Let's find out. Okay, dim bulbs are in. Yeah, this is the one with the switch which does not turn off. Phew. It's getting to be an expensive radio to fix up. Okay, so we're looking for AVC voltage here. There's a little bit coming up. And well, she's pretty hummy. That's not sounding very good. I thought this worked better than this. I do have an outdoor antenna connected, and what I've done again, I've just clipped the clip lead from the antenna to the insulation of the antenna lead wire here. They're not actually metallically connected. Well, let's tune around. Now I was pretty sure I picked something up. Sounds like a radio. Maybe I've got it on shortwave. Sounds more like what you expect on broadcast in this house. I thought this radio was working. Oh, I'm looking at it and thinking, oh my gosh, they've written the dial information upside down on this radio. Yeah. There's a station there. I can hear it. Okay, let's do the direct, more and more direct connection here, because we're not getting too much on this. Direct.
Help you savor all the freshest summer flavors, like a basket of local Ontario strawberries for just $2.99 each till June 26th.
It's $2.99 per basket, not per berry.
Your local Metro. Metro.ca.
Darn noise. Okay. So, sounds pretty good. I don't hear a lot of distortion here. Let's turn it up a bit. Cover your ears. Very good. Sounds very good. You're tuning again? Try a stronger station here. Not much stronger.
And velocity hasn't looked as sharp. I think it's becoming more of a player that, it has to be McDavid.
Okay, what do we see on our different instruments here? Let's start with this. So this is now 5 volts full scale. This is the AVC voltage. The other radio was hitting 7 volts, wasn't it? And this is only 3 here. Different antenna arrangement. Different. So I could connect this antenna to the chassis. We get a little bit of a, I don't know what's happening there. We get an increase. What's it sound like? Yeah, it's better. Let's leave it connected.
Maybe Team Canada's not so bad after all. Maybe
So, tune the radio, get the maximum here.
I'm kind of with you. You don't pay $10 million for a goalie. Sure, if you don't have a defense behind you, I think having a $10 million
Canadian Sports Channel talking about hockey. Hey, anybody watching the hockey game last night? I did. Yeah, next game is going to be really exciting.
really help things.
Edmonton versus Florida. Okay, or the way some of us might see it in Canada. Canada versus the States. We might see it that way.
The guys making saves that count.
And if you're Canadian, you like every other country in the world, you love to beat the Americans at sports. Yeah, not easy.
And it always goes back to Toronto, but maybe
Okay, we'll look at the scope now, and we'll see what's going on there. Now remember, the last radio, the audio was visible without the capacitor. Make it a little more sensitive here. I'm on the DC too. I'm going to put it on AC here and make it more sensitive.
When you show me a good goaltender, I'll show you a good defensive corner.
So there's the audio.
The conversation has really shifted on a lot of these guys from games 1 through 3.
Where I think you shouldn't see it.
Now, but
I'm on the capacitor side of the 2.2 megohm resistor. So I'm on the filtered side. If we go on the other side, let me go on the other side of this resistor, and we should see an unfiltered version of this. Okay, off, and making sure I pick the right terminal right here. Well, I did. Okay, that's interesting. So there's RF in here now, but the audio is not much different. It's not at all what I would expect. So so go across the resistor again to the capacitor side or the grid side. Oh, for crying out loud! You know what I'm moving? I'm moving the voltmeter. Oh, wait a minute. Wait a minute. I'm going to change things here. I'm going to change the video here a little bit. Something interesting just happened. Okay, let's see the interesting thing here. The interesting thing was I thought I was moving my scope lead across the resistor and then looking at the result, but I didn't. I left the scope lead on the capacitor side or the grid side of this big resistor, and I moved the clip lead for the voltmeter. What happened here? Take it off. This whole thing has become different. What? How? Okay, it's a much higher voltage over here. You can see the meter go right over. Six 15 volt scale. That's 6 to 7 volts on that side of the big resistor, and on the grid side or the business side, it's only half as much. Where'd it go? Well, like, where would it go? And why is my scope looking different every time I do this? Because I'm not really watching it here. Well, where did the RF go? Why did the scope show a bunch of RF and now it doesn't? What happened? Oh. What's happening here? Is there a loose wire in this radio? Let me just disconnect the voltmeter for a moment. Okay, so you see RF on the scope. The scope ground is not good? Oh, that could be the case. This is really loose in here. Is that all it is? It's hard to tell when you're wiggling things just what exactly is wiggling. Nothing seems to be reacting here. Nothing's reacting. So I think it must be this lead here is just, this is really terrible how they've done this. This is a very common thing too. How do you, I guess you just have to look at the scope and say, okay, it's good, or no, it's not good. That's terrible. It's exactly what I'm looking for is RF stuff. Why would it be that if you don't ground the lead, you get that RF look? I don't know. Let me ground it. Yeah, it's really bad. It's just as loose as can be, man. I got another lead. Use another test lead here. The reason is because I'm going to be looking for RF and a little bit of so this one's tight. This one's tight. Okay, let's use this. Okay, now, so we have the AVC capacitor in, the original one, at 0.05, looks okay to me. I notice the supply voltage on the far side of this high resistor is about 7 or 8 volts, but on the other side it's only half that. But there shouldn't be any current flowing through that resistor. This is the thing. So, because it's going to grids, and there shouldn't be any grid current. So what's happening here, the only guess I have is that this capacitor is leaky enough in this high impedance circuit, it's very high impedance, couple mega impedance, a little leak is drawing down that voltage. So we're losing a AVC voltage range, if you like, because of this capacitor. That would be my interpretation of it. So what that would mean is if I were to cut the capacitor right now, we would see this voltage, where'd the voltage go? I don't have it connected. We would see the voltage rise up to the same as it is on the other side of the resistor. So let's look at the other side again. You can see the voltage on the 15 volt scale, that's 6 volts. And the thing about this too is it depends how the radio is tuned. Right up there, that's the best I can do. 6 volts there. Meanwhile, so there's 6 volts of AVC available, but on the other side of the big resistor we only have 4 volts, a little less than 4 volts. My guess is it's the capacitor. And same thing with the audio now. I mean, this is, my scope is set very sensitive to 20 millivolts per division, so there's not much there. You know, compared to the AVC voltage, let's do that. If I flip this like this and then go down, down, down until it appears. There it is. Let's check the 0. Oh, wow. 0, not very good. Okay, we're zeroed out. So we're getting a DC of 2 divisions, 0.4 volts DC. Really? That's all? 0.4? Oh, yeah. You know what? I've got the times 10 going on the thing. So it's going to be 0.2, 0.4 times 10, 40. No. What am I doing wrong here? What is happening? What is going totally cockeyed? Am I not reading this right? 0.2. Does the 0 go off? If I flip it, let's go like this. Put it this way. Okay, check the 0. Okay, so now I'm on the 1 volt per division. And I'm getting 2.5 volts. And on the meter, let me hook up the meter here. On the meter, 5 volt scale, 2.5 volts. So the two guys are agreeing. That's good, some agreement. It's good. Now, I'm going to cut that capacitor. I'm going to watch. I can make this more sensitive now. Back to AC. So that's right. So we want to see. Look, that's how much the audio is affecting this in comparison to the DC. Not much. Not much. And we'll go back to making the scope more sensitive. Back to 20. Let me slow it down a bit. I'll put it like that. That's the audio.
Breathe out and find yourself on the culinary journey. Savor exquisite creation and the present moment. Breathe in, breathe out. Book today at thermea.com/whitby.
Oh, I feel so much better already. Holy smokes. Breathe in, breathe out. Now there's something, you know, not many people do that. So it's a good idea. Breathe in and breathe out. And make sure you do it in that order. Don't try breathing out and then breathing in. No, you got to breathe in and then breathe out. Oh my God, what's happened to me? What's happening to me here? You know what I'm doing? I'm delaying the experiment because I'm afraid of failure. That's really what's happening. Okay, we're ready. My cutters, they're ready to go. we're just going to cut the AVC off. Again, checking the voltage. Let me put this back on 15 here. Hoping this rises up to the full available voltage. That will prove or suggest strongly the capacitor is the load. And we're going to get rid of it. At the same time, the audio here should go way up. Let's just make this just a wee bit less sensitive. And a little bit of volume. Okay, here we go. Once again, dramatic effect. Okay, dramatic effect here, that's for sure. Now the audio is competing with the DC voltage. And what is the DC voltage? It only went up a little bit. How come? And radio sound didn't change from what I could notice. Well, mostly because this voltage didn't change much. So let's measure the other side. So we've got 4, almost 5 here. Oh, we got the same here. So it did work. So just under 5. Just over 5. So there still is a little bit of voltage. Still a little bit of current flow going through there. Okay, we're going to do the make and break thing here. So we want this hooked up here. Okay, AVC voltage on the meter. Make and break. You see, when I hook it up, the voltage drops. Take it away, voltage goes up. Not as much as I expected, though. Now, you're not even looking at the scope. I wasn't. Let's look at the scope. Put it in, the audio goes away. Take it off, the audio returns. So it's quite clear now to me. What I consider the AVC bucket is really also a major filter, filtering out audio signals. Again, the audio signal is going to go back. It's going to get on the grids of the two RF tubes in here. I suppose you could get something called intermodulation occurring. I think that might be the right word for it. Seems to me it's a bad idea to have audio get on those grids, but ultimately the signal from those tubes has to be RF to continue through the radio. So the audio signal just can't get anywhere unless it does this intermodulation thing or modulates the RF that's coming through. That's kind of weird. If it modulated the RF and it's the same signal, you've got to be a feedback situation there. Amazing to me, you can cut this capacitor out and nothing dramatic seems to happen. And why would there still be a voltage difference across that resistor? I wonder if we can look at the schematic and figure that one out. Let's take a look at the schematic. Just see if we can rationalize this. Just turn the radio. Oh, it is turned down. Okay. So this is the capacitor we've been playing with. This circuit goes this way to a grid and nowhere else. We go down here, we go through another big resistor, and we get to a third grid here. Holy smokes, that's hard to follow, but it can be followed. So the grid is just an open wire in a vacuum. But this way, look at this. It's going here, going through a capacitor. Oh my gosh, this is the tuning capacitor, trimmer or tuning capacitor here, I'm not sure. Down through here. Oh, help me, I'm going through the switch here. Well, you know what? could be somewhere down all through this stuff that there could be some kind of current leak or current flow, like even through this guy. Could be, maybe this guy's leaking a little bit. 1,000 picofarad. It's got to be. It's a .001. This might be. We don't have a parts list on this one, do we? No, we do not. Do not have a parts list. Could be mica. Might not be mica. If this is mica, probably not leaking. Could be leaking though. But if it's wax, it's definitely leaking. They put it in picofarad, so that's a hint that it's mica instead of putting .0001 microfarads here. We should try to find this capacitor. Yeah, we continue the experiment. This might be the leak, pulling down the AVC voltage. What else could it be? The leak has to go through here, doesn't it? Where else can it leak? It has to get through here. I think it's almost certain this guy's a little bit leaky. And he's on pin 8 of this 12SA7. Okay, pin 8, 12SA7. Ooh, are these in? Yeah, these are in their numbered order, I'm sure. That's why all these little wires are showing inside to try to relate the terminal here to the element. Anyway, I say some stupid stuff sometimes. That's not stupid. What I just said was stupid. I'll get off this quick. I've gotten a little excited. That's what's happened here. Gotten a little excited. So we want to track down that particular capacitor. Let me just pop this up on the screen again here for me. So we want to look for pin 8 of the 12SA7 tube. 12SA7 is this tube. Pin 8. Pin 8 is right here, and the capacitor in question is right here. See the size of that? This may not be mica. There's another one down here. These may not be mica. When they get this big, sometimes they're hiding a square wax capacitor. Let's change this one out. A .001 is easy for me to put in a new one. And see if we don't lose this voltage effect of voltage drop problem. That's the plan. Sounds interesting. I like it. Time for some coffee though. Okay, power's off, and I'm gonna pull out the plug 2. Let's get this out of here. I need a clip lead. I think there's one of these in the other radio, exactly like this. Okay, here it is. Was this made by a company called Micromold? Micamold. Aerovox, made in Canada. Doesn't say anything about it, what's inside it. Let's test it. We'll find out. First we're going to test it. Because if it's a mica capacitor, it's not so likely to be a problem. From my experience. I can always say that, kind of that little caveat there means I can get away with saying almost anything. What do you say? Oh my gosh. Well, it's perfect. According to this, it's a perfect. This is supposed to be 1,000 picofarads. It's right on the money. Uh-oh. Didn't need to do that. Let's give it the pressure test over here. because this high impedance circuit can be disturbed by a very small leak. Okay, sorry, I still have the scope on the screen there, but I'm going to leave it. We're just going to clip this guy on here. I'm getting egg on my face here. Hey, having clipped that out, we could then run the radio and look and see what the voltage drop is. There's no possibility of a leak through this because it's out here. Or put in a new capacitor. There's no chance of a leak through the new capacitor either, so that's probably a better way to go. Okay, so we're starting off at 50 volts. What do you do? Popped right open. You see how fast that one opened? Boom! Wow, that's really fast. So there's nothing wrong with this capacitor at all. You know, when you get up at 450, I don't even know what the rating is. Probably going up too high. 350, it's not quite opening. But as capacitors go, this guy's just fine. I'm sorry, buddy. I ended your career prematurely. Hey, we have something in common. Yes, we do. Okay. Well, I'm going to put in a replacement. I'm just going to put in a tubular capacitor as a replacement. I don't think. What is inside this? Do we really want to know what's inside this? I need a better tool. I'm going to crush it open. We will do that in a moment. I'm going to put in a new capacitor here. Okay. Well, it was soldering in the capacitor. I was thinking, you know, another thing I could have done was change the band switch. Move the band switch around. That changes some of the component connections in the front a little bit, coils and stuff. Maybe I'd find something out there. There's the new capacitor in place. Okay, and we have not got. Yes, we do. We have that's the ground. That's the voltmeter. That's the scope. Everything's connected still. Everything is connected. Okay, so we're gonna power up. Powering up. Then we will look for the variation in the AVC voltage once we. It's really low here. Oh, there it goes. Check the tuning. It's right on. So we're only at 5 here. I thought it was 7 was what we were going for. Let's see. Go across. 5. There. 5. Huh. Huh. Okay. So we have so it looks like changing this capacitor has somehow reduced the current flow through the 2.2 to get the same voltage on either side. Or did I do something funny here? So we're going to reconnect the AVC capacitor and watch the voltage over here, because the expectation is it drops. Okay. Yep, cut in half. So I think that's absolute evidence of the leak in this capacitor here, which we will now endeavor to change. Oh, I didn't watch the scope. You may have. I didn't. Let me do this again. Yeah, and the audio just. There we go. Okay, big lessons learned here. 10 or 12 years of doing this intensely, and still learning basic lessons. I think that says something about me. Okay, I'm going to change that capacitor now. Okay, New capacitor's in. This is the old one here. It looks to be in really good shape. Like I'm looking for, breaks in the seal on it. It looks good. Even right around where the wire comes out, which usually shows a gap because you flex it on the, when you're removing these things. So, but in the radio it appears to leak. 0.05. Let's go give it a go. Okay, as long as you can see that eye, that's the main thing there. Okay. Now if this shows up to not have a leak, I close down my YouTube channel. 50 volts, and what do you say? Not coming open. So again, I test lots of these capacitors coming out of old radios, and most of them are not quite as, don't show up as bad as this or the others that I've gotten out of that radio. Still bad, but oh man, it's a little awkward here. I'm moving that camera around. So we're ready to do the tests on here now. So I'll hook up the voltmeter and the scope here. We still have the antenna connected, and isn't there one more thing? Was there one more thing? The ground. Ooh. I did take the ground off. So we want to connect the ground. That's right where I soldered the capacitor. Put that there. A little worried this clip lead's going to touch the chassis. That's pretty good. Yeah, that's good. Okay. We are ready. Power on. Once again, I'm sorry about that. I really apologize to you. At least when I talk to my cat, it meows back at me. Okay. The voltage over here. Tuning now. 4.5 volts on here. And on the other side, actually, so close to 5. Just up on 5. So just a tenth of a volt more, or a little less than that. Okay, so, and the audio situation here. So it still looks the same, kind of as it did. This is a very sensitive setting. And comparing again to the actual AVC, and competing with the radio, actual AVC voltage. This is the actual AVC voltage. You can see the movement in it. And I think that's from the audio. So then if I flip this over to I don't need to. So that's really it. That's really all we need to see. So the audio is causing a small variation. I think that's audio. Maybe that's not. Because the audio. Let's do it. Make it more sensitive here. Yeah, I'm not sure that was the audio. Hard to say. Is this sitting in, is there a solid, like a steady center line on this? It's jumping all over the place. That's not going to help. It does seem to jump all over the place, doesn't it? But not to worry about it. It's just a curiosity we're looking at. Okay, radio operation. After fixing the, put this back on. So you could probably put a bigger capacitor in there. You get less of that audio and still not really affect the AVC operation of the radio at all. How about a little jazz in the morning? I'd like to say the reception's good on the radio, but really it's the antenna that's good. So that's Hamilton here. And this is the French CVC. Very good. Okay. I think that's it for today. Tomorrow maybe what I'll do, I'll just clear off the remaining wax capacitors in this radio. And there we go. So I really don't know what to say about this one. I think I should have left it in. That's what I think I should say. But, you know, you don't know. You don't know till you know. And even then, sometimes when you know, you don't know. Thanks a lot for watching today. And like I say, tomorrow we'll just carry on and kind of finish this off. And then we'll be looking at alignment and issues like that on both these radios. And ultimately be able to compare their performance, at least on the broadcast band, and see if there's any real difference between them. Thanks a lot for watching, and go enjoy your day.